Hi everybody and welcome once again to Capricorn Radio with your host James Swagger. I got a quick newscast today. I've been rolling out some newscasts of late with some articles and science issues, and I've got a returning guest today because he's published an article that's been first published. I think there was two articles, one 28-year-old and one 20, and I've offered my good friend Rand Flemeth to come back to talk about it today. So I'd like to welcome Rand back to the show. Hi Rand, welcome to Capricorn Radio once again.
Oh, it's great to be back, James.
Yeah, and I could talk about Earth crust displacement all day because I love the anthropomorphic viewpoint of all this, that, this is important. This is part of us. This is not just some episode in history. This affected us, Rand, If this is what we say is true, and I mean, something happened in the Ice Age, and I think this is the only theory that really tackles it, Rand. And you wrote two articles that, which obviously one hadn't been published before, and one was a 28-year-old one and one's 20, and you've just recently put them on your homepage and phlegmath.com. That's phlegm-ath.com, and I'll put the link in the YouTube description. But wonderful articles, Rand. Why did you not publish these before?
The first one, I tried a couple of places to publish them,
right.
But there was completely closed mind about the idea of rapid polar wandering or Earth crust displacement. During that time, there wasn't. I had been very fortunate to have been published in the Anthropological Journal about agriculture
right.
in 1981,
mm-hmm.
But the climate was pretty bad, and it still is. Nobody's really seriously looking at these fundamental questions.
Let me just say, Rand,
about our past.
Let me just say at the start of your article, you say, this is on the 28-year-old one, you say, this is a think piece on the Ice Ages written in 1985. The current poverty of thought on the issue of the Ice Ages is highlighted by the fact that this 80-year-old paper is still relevant today. And that is true, Rand, and that's why I wanted to bring you on the show, because there's nothing in the article that's outdated, and there's nobody tackling this. And I think you're the only one that really addresses this in a scholarly manner, Rand. And I will say that, and I love what you do. I really do. But there was a couple of things in there that I hadn't been aware of. And in the second article, the 20-year-old one. But let's get into some of it, Rand. I mean,
sure.
These articles are like mini books, by the way, I should say for the listeners. They're like little mini books, so that's what I like about them. They're detailed, they got all the references there, and it's just like a published paper, But I mean, this forest that was discovered, this is the key thing, Rand. There was a forest discovered in Antarctica, and it's just thrown everything up in the air. Perhaps maybe just tell us about that.
The fact is that it's a deciduous southern beech forest, and it's right underneath the South Pole.
Mm.
It's only like 250 miles from the South Pole.
Wow.
And, this is under 1,830 meters above sea level.
At the South Pole.
And the ice there is probably a kilometer thick.
Wow.
So you have under there, when you go down there, this is, again, like I say, this is only 250 miles from the pole, South Pole. You go down there, you find evidence of a deciduous southern beech forest. And they date it between 2 and 3 million years ago. So, it's not, directly related to Earth crust displacement in that sense, but it is in this sense that the current paradigm of plate tectonics, which I don't dispute. People keep saying I'm disputing it and that it superseded the Earth crust displacement and all this stuff. They are different whole Earth theories which are sister theories in my view.
Yes.
Plate tectonics it works from a gradualist assumption. And as I explained in this article, Earth crust displacement works from a punctuationalist assumption. That is, there are long periods of slow, gradual changes, and then there's periods of punctuated change when major events occur.
Mm-hmm.
And that's what punctuationalism is. And it was put forward by Stephen Jay Gould in their mid-60s. He was quite an excellent writer, Harvard professor. He well-known writer. He died of cancer not too too long ago. I actually met him personally once
Right.
in Victoria and got him to sign one of his books, which is a treasure of mine.
Wonderful.
Yeah, he wrote a lot. He wrote for a lot of articles for Natural History magazine, and those turned into books. And his books are just, well, he's one of these scientists who has the ability to write and engage, and he brings things into common, compares things to everyday life. So he's one of these sort of Attenboroughs of writing, if you like.
Yeah.
And so he was a great thing, and he and another Niles Eldridge put forward the idea that uniformitarianism, which is the prevailing paradigm of geology, is misguided in the sense that it is an ambiguous idea. It contains two ideas rather than one, but it parades itself as one idea, the one scientific perspective. But there are two ideas in there, and he in this article I explain how he explained in 1965 that there's the idea of physical laws being invariant, that they're always uniform throughout the universe, and that is an assumption that of all science.
Yeah.
And so he has no dispute with that. The other element of it is gradualism. Gradualism can explain everything, and he goes and he says, no, I'm sorry, gradualism can explain a lot, but it can't explain everything.
Yeah.
And that's where this beech tree forest underneath the South Pole comes into play, because to get that part of Antarctica into a temperate zone, which would be required to grow these plants, you have to have change that is much more rapid than just 3 million years. The plate tectonics in 3 million years cannot move Antarctica into a temperate zone. In 3 million years, it just can't do it.
Throws a major problem out there, doesn't it? There's a major problem now. It may be 2 million years versus 50 million years, but plate tectonics doesn't work anymore. Not to explain the forest anyway. It still works, but it still works. But
plate tectonics works for all the problems that it's trying to explain. Earthquakes, uplifts, downlifts, all the things volcanoes, the things that it's trying to explain, the subduction zones, all the stuff that it's doing fine, and I'm not disputing that. What Hapgood and I have disputed with plate tectonics is that it is the whole. It explains everything about the Earth, and we're saying no. There are events such as the end of the Ice Age, origins of agriculture, mass extinctions, that happen in what cannot be assumed gradualist way.
Yeah.
It is a rapid way. And so that's why the paradigm of uniformitarianism, we believe, is obsolete. Incorporates it by saying, yes, normally gradualism, but occasionally punctuated change. So that's what punctuationalism has superseded uniformitarianism. This is where the real shift is happening. It's at the philosophy of science level, not at the science per se, because punctuationalism applies in anthropology and archaeology as well as geology. So this is a big scale change that Gould and Eldridge put forward in the mid-'60s, which normally takes 50, 60 years to be incorporated, and we're getting to that point now.
Yeah, and here's the thing. So, this is why rapid polar wanderings come about. Now, rapid polar wanderings probably saying more than that. It's saying within thousands of years, not an abrupt change even perhaps like this, that this could happen. Like, it's not just, yes, the beech theory, the beech forest throws out the everything in the midst, and it's got problems with it. But this rapid polar wandering is the theory, and let's tie in the Martian lithosphere, because there's evidence that somebody's took this and put this to the Martian system, and perhaps there's polar wandering there too.
What happened was Peter Schultz, who was investigating Mars, noticed that that when an asteroid or a comet or anything hits the Martian surface, and it has a crater impact that has different types of signatures. The signatures that occur in the polar area are unique. They're different from ones when you're hit in the middle of the planet. But when a crater is formed at the pole, it has a specific type of signature. And so what Schultz did was he looked around the globe of Mars and said, are there places where these polar attributed craters are located outside the current polar zone in Mars? And he found them, and he also found them near the equator, and he found that they were antipodal. That is, there was ones on either side of the planet, exact opposite sides of the planet.
Wow!
And so that told him that at one time these crater that part of the Martian surface was at the pole. Both sides were at the pole, which are currently at the equator. And the only way he could explain that would be that if the outer crust of Mars occasionally displaces,
mm-hmm.
and it would have to be relatively rapid to do that because it's not like plate tectonics is working on Mars. Mars has got more of a shell outside. So,
what about the size of Mars as well? Would the size of Earth not have more liquid inside it, more viscosity or less viscosity, I should say?
Well, sure. Since the Earth is larger, that's true. But the main thing that's different about the Earth compared to Mars is that crater impacts get absorbed by vegetation and disappear in a sense from the site.
Mm-hmm.
You know, they're going down and they're actually physically disappearing from the surface of the Earth. So the Earth is a much more active and volatile.
It's erasing all the evidence.
Planet.
It's erasing all the evidence in a way, Rand.
Yeah, you're aging it all away. Whereas on Mars, because it's so barren and everything, that evidence is starkly there.
Mm.
So the main thing about the whole thing about being that Mars's crust occasionally displaces, according to this article, which was written in 1985. The thing is that we can apply that same methodology to the Earth, and when we do, we find that we're finding that the great ice sheets on Earth are antipodal, that is central Greenland and eastern Antarctica,
mm-hmm.
and yet they're lopsided relative to the Earth's axis.
Yeah.
So they're not right over the poles, they're to the side.
Yeah.
And so that would be, if you were looking at the Earth objectively, if you had just arrived at Earth from some other solar system and you saw, here's a planet that has its ice lopsided and antipodal, that means that the crust shifts here.
Mm-hmm.
That would be the logical conclusion. That anybody who wasn't fixated within the paradigms of the planet would have when they looked upon this planet.
But this is the thing, Rand. Earth crust displacement directly, absorbs this as a theory. It takes all the information in. It's looking at it in a scientific manner. It's really addressing it, isn't it? This Earth crust displacement is addressing all these issues.
It is, and it isn't just a question of the antipodal ice as well. It's about the rapidity of the changes that occur. The assumptions of gradualism and uniformitarianism are shattered by the fact that an ice sheet was on North America the size of the one on Antarctica like 12,000 years ago, and now is gone, and all we have is Great Lakes.
Mm-hmm.
That's a rapid 12,000 years, we go from ice sheets 2 or 3 miles thick on over New York and Chicago and Detroit, and now you have lakes. 12,000 years later. I mean, plate tectonics cannot account for that. Mm-hmm. And we have to have some whole Earth theory that it can explain these rapid changes, and we believe that Earth crust displacement, which is just simply a better articulation of rapid polar wandering,